Good day, dearest learners. I am Miss Anjan Vitalas, your math teacher for today. It's another episode of wonderful learning that we will be experiencing in this video lesson. Prepare a printed module, notebook, and pen for taking notes. Are you ready? Okay, these are our objectives for today. Today, you're expected or you're able to, number one, determine the congruent triangles. Second, prove that the two triangles are congruent using the postulates and theorems. And third, solve corresponding parts of congruent triangles.
Are you one of these people? Wearing face mask below your nose just to catch up your breath because of heat or from exercising? Wearing face mask under your chin? Or setting aside the face mask because you want to drink or eat? Oh no, you need to stop these practices. According to an infectious disease expert, Dr. Amesh A. Adalha, senior scholar of the Johns Hopkins Center for Health Security, if you're going to wear a mask, it needs to be worn correctly to be effective. Wearing it in a way that excludes your mouth and nose doesn't serve any purpose. He also added that to move it to your forehead or chin involves touching the mask, which could contaminate it. Dr. William Schaffner, an infectious disease specialist and professor at the Vanderbilt University School of Medicine, agrees to the latter statement. As he said, you want to touch your mask as little as possible. While you're out and about, it's possible to make contact with a surface that is contaminated with the virus. So, touching your face mask with unclean hands may actually transfer the virus, if you happen upon it, to the exact area you don't want it, your face. So, how to avoid these harmful consequences? By using lanyard. According to Reader's Digest, one doctor has suggested an excellent way to keep your face mask to hand at all times by placing your face mask on a lanyard. You can keep your hands free for other things. Your mask will always be close by, so you can slip it on at a moment's notice. By using a lanyard, you keep your mask close by, but you only have to touch the straps. The lanyard will also keep your mask facing the same way, so there's no risk that you switch sides and place the outer layer directly on your face. This is great when you're eating or drinking, hiking, and taking wonderful pictures. Just like Anne, she find very convenient using lanyard. To have some additional color for lanyard to fit the color of the dress, she decided to buy another lanyard that is the same length to her existing one. So, she has now two different lanyards, which are equal in length. Speaking of equal length, this is very related to our new lesson this week. Okay, shall we begin?
Today, we're going to discuss about triangle congruence. But before that, let's have a short recap. When do the two figures congruent? It is when two figures have the same size. Take for example, as you can see, you have your segment AB and segment CD, in which segment AD has a length of 10 units and segment CD has also a length of 10 units. So since they have the same size or length, meaning AB is equal to CD, meaning they have the same length. So therefore, segment AB is congruent to segment CD. How about two congruent triangles? So as you can see, you have a triangle and another triangle, and they have three corresponding angles and also three corresponding sides. So if you have two congruent triangles, we mean everything about them is congruent, meaning all three pairs of corresponding angles are congruent, and also all three pairs of corresponding sides are also congruent. Finally, define the congruent triangles. So you have there two triangles are congruent if and only if their corresponding parts are congruent. So this is a biconditional statement. So meaning there are two if-then or conditional statements that we can make out of this. So first, you have there from the hypothesis to conclusion. So you have there the first conditional statement. If two triangles are congruent, then their corresponding parts are congruent. On the other hand, from conclusion to hypothesis, if the corresponding parts of two triangles are congruent, then they are congruent. Okay, let's have the first conditional statement. So again, you have your if two triangles are congruent, then their corresponding parts are congruent. So take for example, you have your triangle ABC is congruent to triangle DEF. So again, the hypothesis here is if the two triangles are congruent. So triangle ABC is congruent to triangle DEF. So that follows from this definition, then their corresponding parts are congruent. So what are those corresponding parts? Of course, you have their 6 parts, the 3 triangles and 3 sides. So it follows angle A, which corresponds to angle D, meaning to say they are congruent. Angle A is congruent to angle D. Then angle B is congruent to angle E. Angle C is congruent to angle F. And then sides, corresponding sides, which are congruent. Segment AB is congruent to segment DE. And then segment BC is congruent to segment EF. And lastly, segment AC is congruent to segment DF. Okay, let's have the reverse one. Oh, you have here, if the corresponding parts of two triangles are congruent, then they are, or the triangles are congruent. So we have here an abbreviation for this definition, which is CPCTC, meaning to say corresponding parts of congruent triangles are congruent. So it's easy to memorize. Okay, let's have example for that definition. Again, if the corresponding parts, 3 sides and 3 angles of two triangles are congruent, then they are congruent. So you have your given triangle ABC and triangle DEF. So as seen in the drawing. So the corresponding parts that are congruent, such as segment AB is congruent with segment DE, segment BC is congruent to segment EF, segment AC is congruent to segment DF. And then for the angles, angle A is congruent to angle D. And then angle B is congruent to angle E. And then angle C is congruent to angle F. So you have here 6 corresponding parts that are congruent. So then that follows that the two triangles are congruent, which are triangle ABC and triangle DEF. Based on our definition, in order to determine or show that the two triangles are congruent, you need 6 congruent corresponding parts. It is indeed tasking and time-consuming. So there are ways easier and quicker to use to prove that the two triangles are congruent. These are postulates. So I will give you 3 postulates here. Okay, the first one is the SSS congruence postulate. The next is the SAS postulate. And the third one is the ASA postulate. Okay, what is this SSS congruence postulate? Or it is called side, side, side. So just easy to recall, 3 sides. So as you can see here, you have your 2 triangles. So but let me define or describe what is SSS congruence postulate. So you have here, if the 3 sides of one triangle are congruent to the corresponding 3 sides of another triangle, then the triangles are congruent. So you have here triangle ABC and triangle DEF. So the condition of for this postulate, you need 3 corresponding sides that are congruent. Then you can say or you can prove that the 2 triangles are congruent. So given here, segment AB is congruent to segment DE, segment BC is congruent to segment EF, segment AC is congruent to segment DF. So you have here 3 corresponding sides that are congruent. So by this SSS congruence postulate, we can now say that triangle ABC is congruent to triangle DEF. The next one is side angle side or the SAS congruence postulate. It says here, if the 2 sides and an included angle of one triangle are congruent to the corresponding 2 sides and the included angle of another triangle, then the triangles are congruent. But what do you mean by included angle? So included angle is an angle formed by 2 adjacent sides. So for example here, for triangle ABC, so you have your side or segment AB and segment AC. So forming from these 2 sides, you have your angle A that is called included angle. Another one for triangle DEF. So you have your segment DE or side DE and segment DF or side DF. So forming here an angle that is called included angle, angle D. Okay. So again for this SAS, you need 2 sides and an included angle. So given segment AB as seen also in the drawing, segment AB, you have a symbol that means to say they are congruent. Segment AB is congruent to segment DE. And angle A is congruent to angle D, which are both included angles. And segment AC is congruent to segment DF. So based on this congruence postulate, we can now say the triangle ABC is congruent to triangle DEF. The third congruence postulate is the angle side angle or ASA congruence postulate. It describes here if 2 angles and the included side of one triangle are congruent to the corresponding 2 angles and an included side of another triangle, then the triangles are congruent. So from this postulate, you need 2 angles and an included side. So what is included side? Included side is formed by 2 adjacent angles. So as seen here, example, triangle ABC, you have your angle A and angle B, they're adjacent, or so we say consecutive angles. So Angle A and angle B, they are adjacent, and of course, their common side, or yes, common segment is segment AB. So segment AB is called included side. On the other hand, in triangle DEF, so you have your angle D and angle E. So their common side is segment DE. That is called included side. Okay. So from this example, from these two triangles, so you have your angle A is congruent to angle D, an angle. Now, second, segment AB is congruent to segment DE, which are included sides. And third, you have your angle B rather, is congruent to angle E. So we have your angle, side, angle. So from this given, we can say the triangle ABC is congruent to triangle DEF. We're done with the three congruence postulates. Now let's proceed to the congruence theorem. This is called angle side, or AES congruence theorem. So here, if two angles and a non-included side of one triangle are congruent to the corresponding two angles and a non-included side of another triangle, then the triangles are congruent. So as you can see here, for triangle ABC and triangle DF, so you have here angle A is congruent to angle D. So you have there one hash line or one hash mark. So angle A is congruent to angle D, and then angle B is congruent to angle E, two hash marks, and segment BC is congruent to segment EF. So these two segments are non-included side. So they are not common side of the given two sides. Two angles. So you have your angle side. So from this given, you can say, or we can conclude that the triangle ABC is congruent to triangle DEF by AAS congruence theorem. Now let's have example on how to determine if the two triangles are congruent using the given postulate or theorem. Okay, example number 1. So I'm using here the red highlight, or the pointer. So you have your one hash mark for this triangle corresponds to another one hash mark, which means to say these two corresponding sides are congruent. An angle, one hash mark, and also one hash mark here, and two hash marks for this side, and another two hash marks for this side of this other triangle. And notice this angle is unincluded angle. Why? This is common angle for the two consecutive sides. Also this, also an included angle. So from these two triangles, we can say that the two triangles are congruent. Why? Because it's side, included angle, side, or that is SAS congruence theorem. Okay, now let's have another triangles. So here, you have an angle which has one hash mark, corresponds to this angle, one hash mark also, and this side, one hash mark, is also side. This angle, two hash marks, this is congruent to this corresponding angle. And notice, this side is unincluded side, common side to the two given angle. The same with this side of this other triangle. So, meaning to say, the two triangles are congruent by angle, side, angle, or ASA congruence postulate. Okay, let's have third example. So you have here given this triangle. You have there an angle, one hash mark, and another angle here, one hash mark also. This side, one hash mark. This is congruent to this side. And this angle, side with two hash marks is congruent to this corresponding side, meaning this is angle, side, side. Okay, or that is side, side, angle. But there is no SSA. So we cannot say that these two given triangles are congruent since the information given is not enough. Okay, let's have fourth example. So we have here this side, one hash mark, and another side, also one hash mark, meaning to say these two corresponding sides are congruent. Another angle here, one hash mark, is congruent to this angle. Other angle here, two hash marks, congruent to this corresponding angle. So, meaning to say this is angle, side, or shall we say, side, angle, angle. Is there side, angle, angle, or angle, angle, side? Yes, there is. Angle, angle, side, that is congruence theorem. So we can say that these two given triangles are congruent. Now, let's have fifth example. So you have there two triangles. As you can see, they have common side, this side. So from this, we can say that this side is congruent to itself by reflexive property. So one side already, and another angle. This angle is congruent to this angle of this other triangle. And this side is congruent to this corresponding side. So as you can see, notice side and this angle, this is very obvious that this is an included angle on another side. So side, angle, side. So these two triangles are congruent by SAS congruence postulate. Okay, last one. Yeah, there are two triangles. So from these two triangles, as you observe, you have two common, two segments that intersects. Okay, so two segments that intersect. So from these two segments that intersect, they form vertical angles. So vertical angles, again, these are angles formed by two intersecting lines or two intersecting segments. So because these are vertical angles, that follows that they are congruent by vertical angle theorem. Vertical angles are congruent. So you have your angle, not one corresponding angle that is congruent. Here, one side, a side which is congruent to this corresponding side. Another side, also congruent to this corresponding side. So notice this angle, very obvious, this is included angle. So meaning this is side, angle, side. So these two triangles are congruent by SAS congruence postulate. Okay, let's have seventh example. So you have there, this is the same case with the previous example. So these two triangles made vertical angles. So as I've said, vertical angles are congruent. So we are angle and here a side that is congruent to this corresponding side. Okay, and another angle congruent to this corresponding angle. So you have angle, angle, side. So by AAS congruence theorem, we can say that these two triangles are congruent. Another example, yeah, where as you can see, they have common side or common segment. So this common segment can be, or we can say that is congruent to itself by reflexive property. So you have their side, another side, which is congruent to this corresponding side. Another angle, so you have side, side, angle. But the side-side angle does not exist. So we cannot say that these two triangles are congruent. The information is not enough. Now let's proceed to solving problems involving triangle congruence. So you have your example number 1. Mara bought matching triangular pendants for herself and her sister in the shapes shown below. What is the value of x? So you have their triangular pendants, triangle ABC and triangle JKL. So as you see here, AB corresponds to segment JK. They have the same measure, 3 centimeters. So they are congruent. Segment AC is also corresponds to segment JL. They are both 3 centimeters, meaning to say they are congruent also. And segment BC and KL, though the given length are not specific, but from the given problem, it says here matching triangular pendants. So we can assume that the two triangles are congruent by SSS congruence postulate. So if you have three sides, corresponding sides congruent, you can say or you can conclude that the two triangles, triangle ABC is congruent to triangle JKL. So since that is the case, so we can now find the value of x, in which by CPCTC, corresponding parts of congruent triangles are congruent. So since these two triangles are congruent, it follows that their corresponding parts are congruent. So we can say that segment CB or segment BC is congruent to segment KL. Or if they are congruent, it follows that they have equal in length, or they're equal in length or measure. So substitute CB, segment CB is 4x minus 6, KL is 3x minus 4. And then combine like terms. Okay, transpose 3x to other side, so you have your negative 3x, and transpose negative 6. So to the other side, that becomes plus 6 or positive 6. And then simplify 4x minus 3x, you have your x. And negative 4 plus 6, that is 2. So meaning to say, x is 2. Okay, let's have second example. So in the diagram below, you have a triangle ABC is congruent to triangle VTU. You're asked here to find the measurement of angle T. So as you can see here, since the two triangles are congruent, so it follows that their corresponding parts are congruent by CPCTC. So your goal is to find the measurement of angle T. As you can see here, angle T is congruent to angle B. Angle B corresponds to angle T. So, presumably they are congruent. So, okay. So, let's first, it's easy for us to find the measurement of angle B. How? So, in this triangle, angle A, the measurement of angle A and angle C are given, 50. So we're going to use the concept of the sum of the angles or interior angles of the triangle is equal to 180 degrees. So the measurement of angle A plus the measurement of angle B plus the measurement of angle C is equal to 180 degrees. Okay, substitute. The measurement of angle A is 50 degrees. The measurement of angle B is 70 degrees. Okay, let's have here. It's here. And here the measurement angle B, we're going to find that. So that is equal to 180 degrees. And then you add 50 degrees and 70 degrees, that is sum up to 120 degrees. And then you transpose 120 degrees, that becomes negative 120 degrees or minus 120 degrees. So 180 degrees minus 120 degrees, that is 60 degrees. So meaning to say the measurement of angle B is 60 degrees. But a while ago, I said that angle B corresponds to angle T, meaning they are congruent. So since they are congruent, that follows that they have the same measurement or angle measure. So meaning the measure of angle T is equal to 60 degrees. Okay.
To summarize our lessons, so let's have the postulates. So first, the SSS congruence postulate. So as you can see, it is highlighted three sides. So from SSS, side, side, side. So if the three sides of one triangle are congruent to the corresponding three sides of another triangle, then the triangles are congruent. Second one is the SAS congruence postulate. Here, as you see, two sides and an included angle is being highlighted. So if the two sides and an included angle of one triangle are congruent to the corresponding two sides and the included angle of another triangle, then the triangles are congruent. The third one is the ASA congruence postulate. So highlighted here is the two angles and the included side. So as you can see, there are two A's, and in between them is the S, so which is the included side. If the two angles and the included side of one triangle are congruent to the corresponding two angles and an included side of another triangle, then the triangles are congruent. Lastly, angle-angle side, or the AAS congruence theorem. If two angles and a non-included side of one triangle are congruent to the corresponding two angles and a non-included side of another triangle, then the triangles are congruent.
Okay, class, that's all for this day and see you next meeting. Mabuhay!
Enjoy answering the module!